So for the sake of people joining us through online and whatnot, here is the recording. We are going to start off by doing what was expected from homework. That is chapter 1.6. And I'm going to do it exactly in the way I expect on the assignment. And that is, you must show me intermediate steps, the middle steps. Okay, welcome. So here we go. I guess he was here for a second period. Here we go. I am going to notice that we have an A value of half. We have a H value of -6, and I'll write it out. And I have a K value of -3. So let me write this out. A equals half. The H equals -6 and the K equals -3. I know this looks a little bit weird. Clearly it says +6, but it's actually going in the negative direction, going minus. Okay, so this was that was a part you need to watch out for. This is chapter 1.6. Yes. You probably already have that one. It's the one that you just did. Yeah, I keep on forgetting to do that for you. I'll get a chance to do it soon. All right. So for now, that blue one, the one inside the bracket, the one that affects the X value, you have to be careful for. Cameron, it seems like you're confused. Go to the sheet that says 1.6. No, all right. So here we go. Step 1 on your assignment. Let's pretend this was the assignment. You are to start with the parent function x squared. And that is, so I have plenty of space. So I'm going to make 1, 2, 3, 4 every 2 boxes. If you didn't do that, that's fine. Okay. And then 1, 2, 3, 4. 1, 2, 3, 4, but in the negative direction. Here we go. This is the back of question 1. Yeah. So if we were to sketch this out, my parent function is 0, 1, 4, right? 0, 1, 1, and 2, 4. 0, 0, -1, 1, -2, 4. So this, I'm going to try to draw it as nicely curved as possible. At first, you're going to suck. I did too back in grade 10 and grade 11 and grade 12. Only until I started sketching a lot more, even throughout university, did my curves become nice. Okay, so keep working at it. This is my x squared. Now, when you are transforming, do not do it in any order that you want. You must go from left to right if you don't want to make any careless mistakes. At least that's my opinion. So at first, every A value, every Y value, every height of these points are going to be multiplied by half. We're essentially dividing by a 2. So take a look. Ooh, sorry about that. Here we go. 0 divided by 2 is still a 0. 1 divided by 2, well, it's a half. So it belongs right there. And 4 divided by 2 is a 2. Or rather, 4 multiplied by half is going to be a 2. If you figure out the dots on one side, you know what the dots are on the other side because there's a mirror image. And so 0.5 and 2. The resulting curve, half x squared, is going to be a little bit more smushed than the original. It's going to be flatter than the original. Charlie, question? .5. I was saying you would either divide by 2 or multiply by 0.5, same thing. All right, all that's left. If you can do this, you know what? I'm going to skip a step because I'm pretty sure you can count left, right, and up, down at the same time, sort of like video games or Battleship or whatever you want to call it. But even if you don't want to show me the intermediate step for both of these, that's fine. I'm going to do both at the same time. I'm going to tell myself left 6, down 3. Left 6, down 3. Left 6, down 3. Here we go. From this corner, this vertex. Left 6, 1, 2, 3, 4, 5, 6. Down 3. 1, 2, 3. That's my new vertex. This half point, 1, 2, 3, 4, 5, 6. 1, 2, 3. That point, 1, 2, 3, 4, 5, 6, and then 1, 2, 3. Right there. And if you have one side, you already know the other side. It is there and there. That graph is moved to the left by 6 and moved down by 3. That would be your final graph. If you didn't get that, that's okay, but figure out what you did wrong yesterday versus what you're doing now. And if you figure that out, that's another baby step forward. Shall I give you a moment to see if you want to fix this one? And even if you did it perfectly, can I give you a moment so that you can do the intermediate steps for me? Try to mimic or try to replicate, try to copy what I've done on the left side. You are going to multiply all the y values by -3, and then you are going to move left, right, up, down according to these numbers. A is -3, H is a +4, please be careful. And my K is a +6. Let's see what you got. I'll pause this video and give you maybe 2 minutes. All right, here we go. I am going to get started. I'm going to show you what I would do simply because I have a lot of practice, right? But I'd like you to get there too. Knowing that I have lots of space, and I'm too lazy to do 1, 2, 3, 4. I'm just going to write 2, 4 because I'm not dumb. I know it starts with 1, right? Here we go. 2 and 4. -2, -4, and -4. At some point in your life, you will be too lazy to even write these numbers. Guaranteed. Same with me. And so if you get there now, that's fine. I will start with my parent function always. So it gives me a reference point, a visual cue, something to help me with. I'll make these dots a little bit bigger. You can see it. Now, every single y value will be multiplied by a -3. So it's going to be upside down. 0 multiplied by -3, 1 multiplied by -3, 4 multiplied by -3 is 4, 5, 6, 7, 8, 9, 10, 11, 12. Somewhere down here. Somewhere down there. Welcome, Micah. Yes. Again, the a value is multiplying to the x squared. It's multiplying to the bracket. Well, yes, that's how it's written, right? So if you see a number being multiplied, that's what it means. Welcome. We have that, and we have down there. Okay, so this is my new graph. It's really far. And this is why I want to skip some of the steps. I'm going to do both of these at the same time. I'm going to go to the right by 4. I'm going to go up by 4. I don't want to draw this more than I have to. So take this, move to the right by 4, move up by 4, and then move to the right by 4, up by 6. Yeah, up the right by 4, 1, 2, 3, 4, and then up by 6, 2, 1, 2, 3, 4, 5, 6. And same with here. And then this one, 1, 2, 3, 4. And this is a 12. I have to go up by 6. So 1, 2, 3, 4, 6. There. So your final should look something like this: -3 x minus 4 squared plus 6. Okay. It's repetitive. It's again and again. You'll see it even today when I ask you to graph something. I'm going to try to connect this idea with something we can do to describe the transformations, not as numbers, but as words. Please be careful. I am going to write out what A and H and K are communicated as in English. You are going to practice that with this here. I'm going to give you the words and see if you can create an equation out of it. Here we go. A is communicated as so. So I'm going to write it as orange. Okay. You write this as a vertical compression, because it got smaller, right? By a factor of half. That's how you communicate it. There's a vertical compression going on. Oh yeah, go for it. The blue is a horizontal shift 6 units left. And the green vertical shift 3 units down. Yes. Yeah. Keywords. Vertical and horizontal, I think you can figure out what's happening to the graph. So you can, that's obvious. Compression is when it's being smushed. But when it's being stretched, we call it a stretch. Just be careful of that. And when you're talking about a stretch, you have to mention that it's a factor of. In English, that means you're multiplying. It's a factor, multiplying, okay? And then all the other ones are just pretty self-explanatory. You tell me what kind of shift it is, and you tell me if it's going left, right, or up, down. Please be careful once again. If it looks like a plus, it's actually a minus. That's why it is going left. And this is going down. I'm going to do it one more time. But in your head, have a guess. Is the orange going to be a vertical compression, or is it going to be a vertical stretch? And how might the negative affect the wording? I'll give you 30 seconds. Just think about it in your head. How would that orange number be communicated? Hey, I knew you'd be here. Late on a late start. Late on a late start. Did you sleep in? Or did you sleep late? All right. Because the graph is being stretched, forget the upside down, it is still becoming thinner. We call this a vertical stretch by a factor of 3. It is not just a 3, we went upside down. So we have to say that there is a reflection on x-axis. The blue, a horizontal shift 4 units right. And the green, a vertical shift 6 units up. Carter made it. Micah said he'd be late. Thanks for that. I appreciate it. A little late, not much. Anyone else I'm missing? Evan is done. Avita's gone. Samantha. Michael still away? Okay, got it. All right. So here's a little bit of logic. If I give it to you as an equation, you should be able to communicate as words. That means if I give it to you as words, you should be able to write out an equation. And with that equation, you should be able to graph it. So you see, it's all part of the same picture. Just gonna have to get to it. Here's the next one. Forget this practice on the bottom. I'm gonna ask you to try, we'll do it together. I'm gonna give you a couple minutes. Let's do this together on the front side of this sheet. On the front side of the sheet, I give you 2 different examples with words. And those are essentially clues, like a puzzle. Figure out the equation that goes with these descriptions. I'm going to give you a minute for that first example on the right. Okay? So for the following, read this carefully, state the equation, and then using that, you can practice graphing. I'm not going to graph with you. I'm going to just let you try that as homework, and you can check the answers online already. But see if you can do that. I'm going to give everybody a minute to see if you can give me this. Question? This one? That's from yesterday. Anyone else who needs the sheet? 1.6. Everything else is online. Okay. All right, everyone. I encourage you to be wrong. What do you know about? I'm going to write it here. What do you know about A, H, and K? Yeah? Right. There's a vertical stretch factor of 2. But how do you know it's positive 2? Right. So these 2 are both clues for A. Now, what the heck does the vertex tell us? That's a little bit of a connection. Right. Where do we start? Where does a vertex start when we're graphing? At 0, 0. So if the vertex went from 0, 0 to 4, -1, that means I must have moved to the right by 4, and I must have moved down by 1. What does that mean? It means that is actually my blue, and that's my green. My horizontal shift is a +4. My vertical shift is a -1. And therefore, f of x is equal to 2x, careful here, -4 minus 1. I can't stress this enough because it's so confusing. The equation writes it as the opposite sign. And that's it. If you can make that connection, you're good. English words, mathematical words, doesn't matter. You'll be able to get the equation and therefore you should be able to graph it. That's the goal. Try number 2. I'm gonna give you slightly less of time to do this. How about 30 seconds? See if you can make out these words. And I'm gonna color code it for you. What is A? It's all patterned here. Well, let's put it this way. Opening downwards tells you something about its sign. Plus or minus. You got 50-50 chance. Opening down. Cameron? Be negative. Next, it has the same shape as 1/2x squared, right? So in other words, it was stretched or compressed. What am I talking about? Continue.
That means it would be half because it's compressed.
Yeah. It's vertically compressed by a factor of that number. So it is basically what this is saying is same shape is like saying congruent, right? In other words, it's identical in shape. In other words, the A value is the same, is what they're saying. So the A value is a half, but it's opening downwards. So put those two clues together, it's got -1/2. They don't mention anything about shifting left or right, so that's a 0. Shifting up, that's a +3. So that means my function is going to be -1/2 x minus 0. The heck would I write that for, right? I don't need that. There it is. And you should be able to graph that. It's all about the graphing. And that brings us to the end of chapter 1. The sheet that you have in front of you, the new one, 1.7, I'm going to read it for you to give you an idea of where everything is going. I'll show you what each question is asking for, and I hope you remember the days that we did it together so you know what to study for tomorrow. Again, tomorrow is an in-class assignment. You can work together, you can argue with each other, you can try to figure out together, you can use a textbook, class notes, internet resources, whatever you need together. But after you do that, of course, everyone's going to hand in their own assignment by themselves. Okay. Questions? Some questions here. Yes, Sage. Pardon me? The 3, you don't have to change. So the H value is that exception. It's the only one where the sign changes. I'm going to try to explain this from observations as soon as we're done this. Yes. Yep. So that would be x minus 4. The b minus 4 you actually need to positive. So it's given as a +4. Right? It's moved to the right by 4 because the vertex is 4. If the H value is 4, in the equation, it shows up as a -4. So that H you always have to be careful of when we're doing the equation. I'm going to try to show you afterwards. These are good questions. I'm sorry, I just got to get through this and then I will bring everyone aside. Whoever's interested, I'll try to show you why that makes sense. Okay, let's move on. So this is today's work. And after I explain it, you'll have the rest of class, which is about 20 minutes to do this. A to F is a quick rundown of everything we've done in chapter 1. And Ryan, you might want to pay attention because this is stuff that you missed because you were joining us a little late, but you're still responsible for it. Okay. Function relation, 1.1. Domain and range, 1.1. Finite differences, 1.2. Function notation, 1.2/1.3. And transformations is essentially 1.4 all the way to 1.7. As you can see, the transformation takes up a big chunk of your time. But some of you will be like, oh, I know this. Ooh, I could practice that. Figure out which ones you are pretty confident with and figure out which ones you have no idea what I'm talking about because you forgot. Organize your time wisely. Let me give you a quick rundown. Oh, and I also remind you, take a break after a 20 to 40 minute session. I wanted to do this for you on my YouTube channel, but I am tired and I don't think I'll be able to do it. So I'm going to ask you to do it instead. If you have something like Spotify, if you have something like an MP3 player, if you have any kind of music list that you can play like iTunes or whatnot, find a bunch of songs that are not lyric heavy, that you are able to listen to without paying attention to the words, right? Not songs that get you to move while you're studying, just like background music that you can play, preferably without lyrics, right? And make a song list that's anywhere from 20 to 40 minutes long. So if you're on average, find 6 or 7 songs that can make a 30-minute playlist and study until that list is done. What I wanted to do was create like ocean sounds or some kind of background noise that you can play so that once that's over, you know that your study session is done. I thought it was a good idea, but I can't find royalty-free music that easily. So you figure it out yourselves, okay? Make your study sessions 20 to 40 minutes. Here we go. Part 1. If I give you a function that looks like this, I'm going to ask you to plug in these values. Here, function notation. Plug in these values to figure out what the y values are when x is this. And then solve for first and second differences. And tell me if it's a function that's a linear, quadratic, or neither. And how do you know? Question. No, it's the same equation I have here. It's the same question. So question 1 all the way, like given this, solve 1, 2, 3, 4, 5. Okay, next. We have just learned it. How do you describe transformations that are applied to x squared? So please describe in words what that does and what that does and what that does to the graph. That was a terrible way of highlighting. Okay, moving on. Sorry, let me finish this. That same equation with the -3, the 2, and the 3, please graph it using what we've just practiced. Here's your domain and range practice. With the graph you've given me, your final graph, can you tell me what the domain and range is of that graph? And then describe the graph based on, is it a function or not, or a relation? What's the vertex? What's the axis of symmetry? What's the opening direction? They are all pieces you have learned in chapter 1. So if there's a part that you get stuck on, just be like, oh, I don't remember this. Go back to the section and figure out what it is and just review. Yes. Correct. So how about I do this one for you? If you plug in a -2, let's see, that becomes a 4 squared 16 -48. I believe that is what it is. No, I just calculated. I plugged in a -2 into the function. That's what this means, right? So let me see if that is actually true. I need a calculator. Here we go. So -4 squared is 16 times a -3 plus 3. Yep, that's a 45. The next one, -1, that's a -3, 9, -27, -24. Right? And you fill in the rest. First differences would be -24 subtracted by -45, which is pardon me? Well, I solved this. What is f of -2? So what I did was plug in -2 inside this equation. Right? Because that's what my x value is. And then you'd have to solve that. I just did it quickly to show you what first differences and second differences, just to remind you. Okay, so this sheet, I think, is a really good way to review what we've done in chapter 1. You'll get an assignment tomorrow, and you have all class to do it. You just walk in, take a piece of paper, and go. If you finish it, hand it in to me before the end of class. If you don't, well, you're going to have a little bit of long weekend homework. So do your best to finish it before you leave, so you can have a math-free 4 days. Yeah? All right. That remaining time, I let you go at 11. So see how much of this you can get done. I'm going to have an answer key available for you online, hopefully before this class is done. And yeah, good work.